Hello, dear students. This is Santosh Nemkar. You are learning physics with Roughbook, our learning companion.
Students, let us see the ray diagrams of lenses. Now, depending upon the position of the object in front of the lens, the nature of the image formed changes. Now, let us take the first case when the object is at infinity. But when we say that the object is at infinity, it does not mean the object in the space or very far off like stars in the sky. It means that with respect to the focal length, if the distance is much greater, then we consider the object at infinity. Now, for example, if the focal length of the lens is 10 to 15 centimeter, compared to that, if we consider a distance, say 4 5 meters, so the distance is much greater than the focal length. So we can consider there the object at infinity. Okay. Now, when the object is at infinity, the nature of the image is real, inverted, highly diminished. That means it almost becomes a point as the distance keeps on increasing and formed on the focal plane. Now, if you want to draw ray diagram, the first important thing is that you will draw lens as y-axis, that is vertical. Then this is horizontal. These points have to be marked at equal distances. That means if this is 2 centimeters, then this has to be 2 centimeters, this has to be 2 centimeters, this has to be 2 centimeters. Now, when we show the object at infinity, we do not show the object actually, we just show a parallel beam incident on the lens. Now, you know that the rays parallel to the principal axis after refraction converge through the focus. And to show that a highly diminished image is formed, we show a small inverted arrow. This image can be captured on the screen. That's why the image is real. Now, which optical instrument forms this kind of image? The image which is formed in our eye lens. The image which is formed in the camera while clicking a far off object, okay, is this kind of image. Even when we use a convex lens as a burning glass, if we face a convex lens towards the sun and on the other side, if we converge those rays, if you place grass or if you place cotton over there, within few minutes the cotton starts burning if you are focusing in the afternoon intense sunlight, because along with the light radiations, even the heat radiations are converged at the focus, because heat radiations also obey the laws of refraction, and large amount of heat is produced at the focus, and therefore the cotton or the grass starts burning. Corresponding diagram, if you want to draw, you can draw the same diagram. Instead of writing the light rays over here, you need to label the heat radiations, or you can complete the ray diagram with respect to oblique beam also. Okay, you can consider oblique beam. These are the heat radiations. Where will these rays converge? So I will draw the focal plane. Now I will draw a line parallel to the incident beam passing through the optical center, and wherever it cuts the focal plane, the rays will converge from this to this point. So large amount of heat is generated and therefore the burning takes place. Now, case 2, when the object still comes closer. When the object is moved from infinity beyond 2f. So case 2, object beyond 2f. Now, again, this instruction will remain the same. A vertical line, that is convex lens as y-axis, principal axis, okay, that's the horizontal line, and these distances should be equal. Okay. Now, you will draw a linear object beyond 2f, and we will consider one ray parallel to the principal axis. After refraction, it passes through the focus. I will choose another ray from the same point passing through the optical center and produce it further. Now actually wherever the two rays intersect, there you will get the position of the image. Now it is sufficient to complete the ray diagram using 3 rays, but if you see previous year's ICSE papers, sometimes they ask you to complete the ray diagram using 3 rays from the same point with the standard rays. Now the third standard ray will be the ray passing through the focus after refraction travel parallel. Now if your working is not accurate, then many a times you draw the third ray through the focus, it doesn't come parallel when you join it to this point. So to avoid this, we can draw the refracted ray first and join this point to the tip of the object. And if it doesn't pass through the focus, wherever the line is cutting the principal axis, mark that point as a focus. Shift the original focus to that point. There will be a difference of hardly 1 to 1.5 millimeters. So wherever the 3 rays meet, at that point you will get the image. So the image formed is diminished. It is formed between F and 2F. It is real. And it is inverted. Now, which optical instrument forms this kind of image? So this kind of image is formed in the camera while taking selfie or clicking photograph of an individual person or individuals. In that case, the image is formed between F and 2F because object is closer. It is beyond 2F. Now, next case is when the object is at 2F. As you move from infinity towards the lens, the image on the other side will keep on moving away and it starts increasing in size. So let us go to case 3 when the object is at 2F. Now when the object is at 2F, as instructed before, you will complete this. Then at 2F you will draw an object. And at 2F on the other side you will draw the image of same size. Now you will draw a ray parallel to the principal axis. And after refraction, join it through the focus. But actually you should join this to the tip of the image, and wherever it cuts, mark that point as focus. If your working is accurate, it will go through exactly the focus which you had marked before. Otherwise, shift the focus. Then second ray is the ray passing through the focus after refraction travel parallel. So once again, I will draw the refracted ray first through this point. And from this point, I will draw a straight line joining to the tip of the object. If your working is correct, it will pass through this F. Otherwise, wherever the line is cutting the principal axis, mark that point as focus. And then join this to this. Once again, I am repeating, ray diagram is sufficient using 2 rays. If the question says that it should be completed using 3 rays, then only you will draw the third ray. Otherwise, you could have drawn any 2 rays, this and this, this and this, or this and this, any 2 rays. So what is the nature of the image? It is real, it is inverted, it is same size as that of the object and formed at 2F on the other side. Now, which optical instrument forms this kind of image? Now, the terrestrial telescope, this kind of refraction takes place in the terrestrial telescope. The lens placed between the objective is a lens facing the object in any optical instrument, and the other lens is eyepiece through which you see. So, in between the objective and eyepiece of terrestrial telescope, there is an additional lens kept. In astronomical telescope, the object at infinity is present in front of the objective, its inverted image is formed on the focal plane, as we have learned in case 1. And then the eyepiece magnifies this image, and therefore the object appears closer, but it appears inverted because this image which is formed is inverted. Now, the intermediate lens which is kept in between helps to invert the inverted image. So the image formed by the object which is present at infinity at the focus of the objective lens. Now this image becomes the object for the intermediate lens, and we adjust this image at a distance of 2f of this lens, and therefore on the other side at 2f you will get the image like what you see in this diagram. And this image which is formed is adjusted within the focal length, and its magnified image is formed, which we are going to do in case number 6 later on. And therefore, since the image is magnified, the object appears closer. Now let us go to the next case, when the object is between f and 2f. Now when the object is between f and 2f, you need to be careful that the object should not be very close to the focus. Because if the object is very close to the focus, the rays will not meet on the paper. So you should draw the object between f and 2f, maybe at the center, maybe slightly closer to f, slightly closer to 2f, but not very close to f. So linear object is drawn. One ray parallel to the principal axis. After refraction, it passes through the focus. Another ray is passing through the optical center, travels undeviated, and wherever they intersect, you get the image over there. Now, if the third ray has to be drawn, then it is the ray passing through the focus after refraction travel parallel. So, I am drawing the refracted ray first, and then I will join this point to the tip of the object. If your working is accurate, it will pass through f. If it doesn't, wherever the line cuts, shift the focus to that point. Now the image which is formed is real, inverted. Now if you see, the image is magnified. The image is magnified and formed beyond 2f. So if you remember all the cases, object was at infinity, the image was on the focal plane. Object beyond 2f, the image still moves further between f and 2f. Object at 2f, the image was at 2f and of the same size. Now when the object is between f and 2f, the image still moves further but increases in size. So the nature of the image is real, inverted, magnified, and formed beyond 2f. Which optical instrument forms this kind of image? So the optical instruments are movie projector, overhead projector, slide projector. All types of projector forms this kind of image. Now the next case is when the object is at f. Now when the object is at the focus, okay, once again the beginning will be the same. The vertical line, that is y-axis, is length. Horizontal line, all these points have to be marked at equal distances. This distance will be same as this distance, will be same as this distance, will be same as this distance. So you will draw the object at focus. One ray parallel after refraction passes through the focus. Another ray I will choose through the optical center, which will travel undeviated. Now if you observe, the rays on the other side of the lens are parallel. So they will never meet even if you produce them further or even if you produce them backward. So if at all I have to draw the third ray, now you know that the tip of this object is a point on the focal plane. So the rays passing through a single point on the focal plane after refraction travel parallel. So I can draw any third random ray and I will draw the refracted ray parallel to these two. Now actually the image is not formed over here. What you can see is a parallel beam of light. But by applying principle of reversibility to case 1, when the object is at infinity, the image is on the focal plane. So if the object is on the focal plane, the image will be at infinity. So experimentally we cannot verify this, but by applying the principle of reversibility of light, I can give the characteristics of the image as real, inverted, highly magnified and formed at infinity. In fact, in many of the experiments where you require a source of parallel beam of light, we use this case. One of the example is the collimator of the spectrometer. Now, when we obtain spectrum, the incident beam on the prism is required to be parallel. So the tube collimator has this kind of arrangement. This is the diagram of a spectrometer. This is collimator tube and this is telescope. Through this you can see the spectrum of the colors. A light source is kept in front of it. There is a slit, and the distance between this slit and there is a convex lens present over here, and the distance between them can be adjusted to be equal to the focal length of this lens, which means that when the light passes through the slit, it is passing through the focus, and therefore the rays which are coming out of this lens will be parallel. So a parallel beam will be incident on the prism. That's how we can make use of this kind of refraction. Okay. Now, next case is when the object is within the focal length. Now, from infinity up to the focus, you get real image. Now, case 6, when the object is between the principal focus and the optical center. Now, as the standard rules, we need to draw the lens and the principal axis with f and 2f at equal distances on both sides. Now, once again you have to remember, when you draw the object between f and o, you should not draw object closer to the focus. You can draw in between f and o, slightly closer to f, slightly closer to o, but not very close to the focus, because if you draw the object closer to the focus, the rays will not meet on the paper. So I am drawing it in between f and o. One ray parallel to the principal axis. After refraction, it passes through the focus. Another ray I can choose through the optical center, which will travel undeviated. And when you produce these rays backward, they appear to meet. In this case, on the other side of the lens, the rays are diverged. So they will not meet this side, but they will meet when they are produced backward, and that's why you get virtual image over here. Now, the third ray is the ray coming from the object having direction through the focus, and such ray after refraction will travel parallel. So I will draw the refracted ray first. The image is over here. This is the refracted ray, and I will join this to the tip of the object, and if I produce it further by dotted line, it should go through f. If it doesn't, then this line, when produced further, wherever it cuts the focal plane, please shift the focus to that point. So once again I am telling you, for drawing ray diagram, 2 rays are sufficient. If the third ray is asked, then you can draw 3 rays. Now the nature of the image is virtual, erect, it is magnified and formed anywhere behind the object. It can be between object and focus, at focus, between f and 2f, at 2f, beyond 2f, anywhere behind the object. So nature of the image is virtual, erect, magnified and formed anywhere behind the, my apologies, behind the lens, behind the object. Please make correction over here. This is object. This kind of image is formed in the eyepiece of telescope, eyepiece of binoculars, simple microscope, reading glasses. All this will give you this kind of refraction, and the image nature is this.
So, dear students, I hope you have enjoyed learning physics with Santosh Nimkar and Roughbook, our learning companion.